There we go.
Hello and welcome to TidyX episode 178. TidyX is a screencast where we go through and explain how our code works, and this is the second time we're recording this. My name's Ellis Hughes. You can find me on various social media sites, but this is TidyX, and I'm totally messing up this intro, so let's get going.
All right, welcome. Thanks for checking in at TidyX. We're on to episode 178, take two. We've had like a billion technical difficulties with our computers and our recording system.
Oh
So
my, it's been rough.
the gods have basically said they don't want episode 178 to take place, but we're going to
We're
gods
going to
be
do it
damned,
anyway.
we're going to try and do it. Cohen, we've got you covered here. We're picking up where we left off. I'm going to just briefly scroll up, show you all the code from 177. Again, this was a viewer submitted question. Cohen McDonald, awesome question about working with some of these JSON files from the FIBA data. So last week, just as a refresher, we yanked in that play-by-play data. It's actually not play-by-play data. It's like action-to-action
Yeah,
data.
it's events that occurred in the
Event
game.
data. Yeah, event data. One of those events is when a player is subbed in or out. And Cohen was after a way of basically figuring out who's on the court and who's not on the court, and then being able to visualize this really cool graph that we're going to make today.
Mm-hmm.
So last week, we kind of went over the nuts and bolts of how to yank this JSON file in, work with it, identify who the starters are, figure out when the ins or outs are, determine the time of the game, all of that fun stuff. So you're going to want to review that before you pick up where we're at here on line 135 at episode 178. So we basically have, just to refresh, we have a data set that we've created in episode 177, which is called lineups over time data frame. You can see that it has all of the numbered actions. So every action that takes place in the game is detailed by probably like a scorer up in the score booth. So like ball out of bounds, steal, block, shot, score, etc., player in or out. And so we have all of these actions. We have the clock time, the period type, and then we have the lineups of both of the teams that are playing each other, and they're nested into lists. And you
Yes.
can see that one of the first major kind of like checks of the work is that these lists should never have more or less than 5 players. So we see 5v5, 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 all the way down. It's 5v5 all the way down. So
Looking
this
good.
week, looking good. So this week we're going to yank this type of data file in, and we're going to muck around with it so that we can get it into a data frame style, so that we can explore this visually in the way that Cohen was looking for. So Ellis, why don't you take us through this first big kind of chunk of code here that's pulling this data in and arranging it into a data frame that we can work with.
Sure thing. Yeah, it's doing a number of things in this series of pipes here. I probably should have broken it up. I try to have my pipes do one specific transformation at a time, and here I'm doing a few. But this was just how my brain was working when I wrote the code here. So I took lineup over time df, which is what Patrick was showing there. And what I do is I select GT through T1 lineup. You could restructure this. So if you wanted to do team 2, it'd be GT through period, and then comma, and then T2 lineup. But here we're just going to do the T1 lineup. And then I'm going to call unnest on T1 lineup. What unnest does is it takes that list call and spreads it. It makes it long, right? It's going to take all the entries there and replicate, or in that list entry of T1, and replicate clock period or GT clock period type for every one of the entries in that list there. So now we've got this long format of here's all the players that were in at this time point here, and I'm going to pivot out wider. Well, actually, no, I'm going to, in line 140, add the is in equals 1 entry here. So now we're just creating a dummy variable through lines 140 and 141. This is going to allow us to then kind of visualize, not in a plot, but in our data frame, every player is going to have that played for T1 is going to have a column, and there'll be a 1 if they're currently in at that time point in the game, or they're going to have a 0 if they are currently out of the game at that point. The pivot wider, the names from, so that's saying the what new columns are going to exist, and so it's T1 lineup, so the players. Values from is in, so we just created that with the line 140 there. We're going to call unique on that because if there's multiple entries for the GT clock period time point, we want to just call unique because there should only be one value. And so we're just going to call unique on that. And then values fill equals 0 is for all the players that didn't have a GT clock period or a period type, they're 0 because they're not in at that point. So now we've got this kind of wide data frame here. We actually want to calculate what point in the game is this, and we want to turn this into a numeric value so we can plot it more easily. We actually did this with was it Alice?
Yeah, we made the scoring worm. That was
Yes,
probably in like TidyX,
like 77 or something like
old
that.
old double digits. Yeah, like
It
60.
was back in the day.
Yeah.
But what we're doing here is we're going to calculate first the quarter time that has elapsed. So we know in FIBA that the quarters are 10 minutes long. We also can see if we look at GT, which is the game time, it calculates GT is recorded from 10 minutes down to 0. So what we're actually going to want to do is first convert the GT into a POSIX CT value. We're going to do this by saying as.POSIX CT on GT, and we're going to say the format is minutes colon seconds. So then it can convert it into a nice numeric value for us. We're going to then convert it via format into minutes dot seconds, and then we're going to call as numeric on that. So what that's going to do is going to construct values that have the time elapsed in the game, but it's minutes dot seconds. So we can actually view it as 10.25 seconds. We recognize that this is not like a proper representation of time because the maximum seconds are going to be 59. And so some of the values are going to be slightly off, but it's going to be close enough for our purposes. And then we're going to subtract 10 minus that value to give us the total elapsed time in that quarter to that point. Now, to pull that up to game time, what we need to do is we do a case one, and we say if the period type is regular, take that elapsed quarter time, add to it how many periods have already elapsed in that game, and add 10 minutes for every period that has already elapsed. So period, so this is the current period it is, minus 1 to take it to what the prior number of periods have elapsed, times 10. So if it's in the second period, that is 2 minus 1, so that's 1 times 10. So 10 minutes already elapsed previously in the previous quarter, plus the current quarter time, right? So it's kind of like weird logic to think about it, but hopefully that makes sense. Then for overtime, the rules for overtime are a little bit different because it's actually going to be the total quarter time, quote unquote, but the periods are actually 5 minutes long. So it's going to be the period of overtime times 5. But then we're also going to add 40 to it because the regular time in a period for a game in FIBA is 40 minutes. So it's 40 minutes plus the total quarter elapsed time in overtime plus number of overtime periods times 5. So
Yeah.
it's a little bit confusing. But yeah,
Here's where
take
we're
a
at.
look at it.
Here's where we're at right now, just to see what it looks like. I'm gonna pull that in. So there's our elapsed time. So we have time that is specific to time within a quarter, counting
Yes.
up to 10 minutes. Unless we're in overtime, it would be 5 minutes. And
Yes.
then we have an elapsed game time, which is basically going from 0 to 40 for a full game, or 0 to 40 plus N for however long that overtime period is going to last.
Exactly. We're now going to pivot it longer again because while we like this wide format for some of the calculations we're going to need to do, it's going to be a lot simpler to do it when it's in a longer format. So we're going to say, hey, pivot longer from 5 to n call minus 2 because those are the players that exist that played in that game because we only added 2 new columns, elapsed quarter time and elapsed game time. So that's why you have the n call minus 2. And we say, hey, make those names player. Let's just convert it into the column player. We're going to then group by player. And now we can calculate. What we want to know is when the player actually went in or out. Because there are times you can see in the head here where like Daniel Thies was in as a starter, in still at the second substitution, the third substitution, and the fourth substitution. It was only at the fifth substitution that they went out of the game.
Mhm.
So what we want to do is for every player, only capture the time periods where they actually went in or out, where they changed their position in the game, basically. And so by doing this filter by true, or so that keeps the first entry, so the start of the game, and then also when they change being in or out, only keep those records. We can then do the second piece here of mutate and add T1 and T2. So T1 would be what is the current time of that action, and then T2 is when is the next action that occurs, so that we can get the duration of when they're in that state. How long were they in that state before they changed? And then we call ungroup because we no longer are wanting to be calculating things by player. So if we run all that,
and we'll
and
give
let's
it
take
a look
a quick
here.
peek at T1 players over time, you can see this is still sorted by action. But like Andreas started the game, and then at time 3 minutes and 65 seconds, or 3.65, had a change in state from being in to out. Or Daniel Thies, as we talked about earlier, started in, so T0 or T1 is 0. And then at 6 minutes and 6.44 minutes, changed state to out. And so now we have this data frame that's long, that has all the information for every single player of the changes of their states, how long they were in those two states from T1 and T2. We also will need to add in max time because while we did the lead of it, that means the very last values are NA. So lead returns a vector that is the same length as the vector you give it, but the last value is an NA because it doesn't know that. So we need to know the maximum time of the game. In this case, we know this game was played to one overtime period. So we just put maximum time 45. You could do an if else statement that calculates, okay, given the number, if it's overtime, calculate the number of periods that existed in overtime and add to that. So there's a little bit of pseudocode, not pseudocode, but some code in there that does that. But it's not very good. We can come out with some improved code if y'all are interested in figuring out how you might do that. But then in line 175 here, we're just going to do a case one. And if the T2 is an A, drop in the max time. Otherwise, leave it as T2 is all that code's doing. So now we've got some prepared code here. We can actually go into the visualization to see in a line plot situation which players are in and which players are out. Patrick, how does this code work?
Yep. So now we have this this cool data set here that we've just been looking at. We're going to filter out the value where the players are actually in. So that's going to be anytime that it's a 1, right? And then we're going to mutate and create some new values. Some of these are just being created for like plotting purposes, for coloring purposes, basically. But mutate player in. So is player a starter? So if the player is a starter, we're going to just create this little kind of Boolean value that allows us to color those players so that they stand out on the plot. Like, hey, we know this guy was a starter and we know these other guys were not starters, right?
Yeah.
So that's the is starter, and the player is, we're basically just setting a factor level here on the players. So we want the players in the plot to come out in a sort of specific way so that they're lined up in a logical way. So let's take a look at what we have with that. So if we run that, we've now got that Boolean value there is starter, and we've basically in some way logically added a level order, or like an ordering to the players, which is what the levels argument does within the factor function.
Yeah, because we don't want it to show up alphabetically, right? We want the order to represent something to us.
Yeah, that's right. We want those starters to be on the top and the non-starters to be on the bottom, so that, you know, if you gave it to a coach, it looks like something that makes logical sense, right?
How they would think about it.
Yeah. We don't need all these columns now for the plotting purposes. We really just need who the player was, what their state was at time one, what their state was at time two. So basically the time periods that they were in or out, and then whether or not they were a starter. Again, Boolean for plotting purposes. And then we just get into kind of like the standard ggplot that we all know and love. We're going to call ggplot, and that's going to set up our little plotting canvas over here. And we're going to use a line segment. So this segment is going to basically give us horizontal lines for each of the y variables. In this case, the y variables are going to be the player, colored by whether they're a starter or not. The x variables are basically saying, hey, within this horizontal geom segment line, let's make sure that we always draw a line that goes from, T1 to T2 for each player, where we're basically drawing in those lines. And when the player isn't in, we're getting rid of the line.
Yep.
There'll be nothing. And then when the player's back in, there'll be a line. And when they're not there, there'll be no line. The line width is going to be 4, so it's relatively thick. We'll give it a GG title, which is basically going to be player roster for team 1, pasted together with the actual team number. And we're grabbing that from the JSON file where each team had like a little bit of a numeric kind of representation. And then the code gave us like their team name. Okay. Yep. The scale wide discrete, limits in reverse basically is just a way of saying, hey, on that y-axis scale, it's going to be a discrete scale. So it's like some sort of categorical or factor variable, and limits in reverse basically say, hey, flip it. Because if you look at our isStarters variable that we're coloring by here, false in alphabetical terms comes before F comes before T. And so let's put the T on top.
Mm-hmm. Well, also, because y is actually the player factor name. And when the player, if we didn't do this, it would list the player that was the first factor on the bottom.
Yes.
And the factor numbers go up across the y-axis. What we actually want is we want the players that started listed on top. And so even though their factor level is the highest level, like level 0 or 1 is Andreas, he would show up on the very bottom, because if you look at your y scale, typically on your plots, 0 starts at 0 y and then goes up from there. And so factors also follow that logic. By saying limits reverse, that means actually no, just flip that.
Yeah, and that's an important part about factors is they have a numerical underpinning to them, which is different than a categorical variable. So that's why sometimes if you have a factor variable and you convert it directly as numeric, you just get the numbered the numbers that underpin that. So that's an important thing to remember. The thing that differentiates factors from character variables is that the ordering is actually meaningful in factor variables. It means something.
Exactly.
The x-axis we're just going to set as continuous. So we've got breaks at 10, 20, 30, 40. Since we have 10-minute quarters, that makes good logical sense. The limits are going to be 0 to 41 to give us a little bit of edge time at the end. And obviously we left out overtime here. So we're just going quarters 1, 2, 3, or 4, and then end. We didn't.
It's going to paste together. So it'll be Q1 and Q2 and Q3 and Q4 end.
Correct. Yeah. So we didn't add a overtime in there.
Correct.
And then some of our theming here. So basically this is just to make it look pretty. We're going to do some stuff with the axis lines, X and Y, to make them black colored, and axis text and the axis ticks are going to be black, and bold the axis text. Same thing with the Y text. The size is going to be a little bit bigger on the y-axis so that the names pop out a little bit larger so they're visible. And then we're just getting rid of the axis titles because essentially they're meaningful. We don't need a y-axis to say players. It's like,
it's not adding information. It's just taking up space.
We can see it's the players, and we're going to get rid of the element, the legend title. So and the legend positions. We get rid of the legend altogether. You could leave that in there if you wanted and put it on the side. It'll shrink the plot. You put it at the top or the bottom. So you could put the position somewhere that basically just says true is starter and false is not. But usually that's going to be pretty apparent to a coach who made the game plan. So,
Yeah. So
so
let's see what this plot looks like.
let's go ahead and see what this looks like. I'm going to extend our plot window here so that we get a full look at it. And cool. So we have a nice looking GG plot here. We can see the starters are in this sort of greenish blue color.
It's the default like alternate color from
Yep.
ggplot. We didn't alter these at all. I mean, what you could do is you could go in and genome scale color discrete, or scale color discrete, and set what the true and false are to maybe be the primary and secondary colors of your team if you wanted to be a little fancy,
Yeah.
and things like that. Here we were like, yeah, it's fine. These colors are fine.
Yeah, you could probably grab a create a separate data set that gives you the team colorings and primary and secondary colors and do all that stuff if you want, depending on how extensive you want to make this. The juice is probably not worth the squeeze in this case. It stands out. We see the starters on top. So, for example, if we're reading left to right, we see Andreas. He came in as a starter. He played for pretty much all of the first quarter, and then he was subbed out, and it looks like he was subbed out for Isaac, who came in and then played from the end of the first quarter all the way through.
That's still the first quarter.
Oh, sorry. That's right. I was looking at this vertical line. He played partial part of the first quarter, left. Andreas came in, who played a bunch more, who then it looks like he left at some point and somebody else jumped in. Looks like Niles jumped in and played across the end of the first quarter into the second quarter. And you can just kind of read it across. You can see where each player came in or out across the game. We could have put, maybe like dashed lines vertically to represent the quarters if we wanted or something like that. There's a ton of options with this.
Yeah. It just depends on what your audience wants. What is the information they're wanting to gather from this? Like what is the value of this plot for them to understand? So maybe this one plot isn't incredibly helpful. In the example that Cohen sent, it has this type of plot, but then what they did is they had a plot where they overlaid a bunch of different games together to see what is the general strategy that the team uses. So when are they often substituting out Andreas, and then who's coming in most of the times, and when are they doing those substitutions? So you could maybe strategize if you're a competing team to go, well, oh, they usually sub in Isaac at this point in the game on average. And so if we want to have a good matchup, we want to make sure to then sub in our person that is good against that other player for whatever reason.
Yeah. Under the assumption that the subs are being directed by time and not directed by tactics. Like every time the opposition put in this other player, we sub in our big man or something like that. So
all of a sudden it becomes
lots of reasons for subs to occur. I think the one thing though we noticed is here at quarter 2 end, which is halftime, we have a bit of an issue where we have 8 players on the court, which means some of these players who were in at the end of quarter 2 accidentally got carried over. And so next week, we're going to work on a way to solve that because we need to pull in the logic that we used in episode 177 to identify who these starters are. We basically have to repeat that whole process for the second quarter and then slam it together with our second half and then slam it together with the first half. And then I'm guessing we would need to do that for overtime as well, and then slap it together with the full game, because that's essentially what you don't want is players traversing those halftime periods and still being looked at as being in.
Yeah, potentially we could do this for every quarter too, and just not make the assumption that they stay in across every quarter. But these are just things. This is why you visualize things, right? Is we thought we had the code. The code made sense to us. It was logical as to how we set it up. But there's context to this that we didn't account for in our code, where it was we just didn't account for. Oh wait, no, at halftime they might not be rolling out the same players they had at the end of the first half at the beginning of the second half. I mean,
Yeah.
that makes sense when you think about it. But the way that we wrote our code, we didn't
Yeah.
look at that.
And it looks like in this one game, we didn't get in any trouble with that between quarters, but you're right. These are like those gotcha moments where maybe if we ran this on a different game, we would get something. Maybe a team in theory changes all 5 players out to start a new quarter, in which
Yeah,
case we would have 10 players in if it was 5 that were ending the quarter and 5 new ones starting the quarter. Um, so those types of gotcha type moments are really important for, to pull out when you visualize your data. So that'll be next week. We're going to try and correct this
yes.
and talk through code that basically can scale a little bit easier to other
Yeah,
games.
and we'll write it in such a way that we can scale it up. So if we wanted to apply, so we have one game code here, and obviously we've kind of built towards that. But we tried to write all our code in such a way that if you change the game code, it should work for any one of these FIBA games, and create this sort of visualization for you without having to do any really customized edits. So actually, what I'd love, I'm going to give you all some homework too. I'd love to hear how you all would deal with this issue and how you would solve it, so you can see and compare against what we do, and make some suggestions to that.
Yeah. And if you do one yourself, send it in. Tidy.explained@gmail.com. Send the code, and maybe we'll have you on
Yeah,
episode to explain your code.
yeah, I'd love to do that. That'd be a
Yeah.
lot of fun.
Yeah.
But with that, I think we have a pretty fun visualization. We showed you how to make it. Some of the code logic needs to be updated, that was going into it, but the code that makes the plot does work. So that, I guess we're going to call episode 178 of TidyX. As I said earlier, my name's Ellis Hughes, and you can find me on various social media sites as Ellis_Hughes.
And my name's Patrick Ward. You can find me on X, OSP at OSP Patrick. You can find the both of us on X at tidy_explained. Of course, easiest way to get in touch with us is on that YouTube channel. Like, subscribe. That really helps us out. We forgot to say it throughout this entire episode,
Yeah.
but like and subscribe if you're still listening. Drop your questions, comments down below. That's the easiest way to get in touch with us.
Even
If you
if
have
you just say
questions,
that you like the episode.
even that. And as always, if you enjoy this work and it's helped you in some way and you'd like to support our work, we do have a Patreon page. We're super appreciative of anything you'd like to give.
Thank you all so much, and keep on exploring your world.